Sample problem number 9. A certain amount of charge is placed within an isolated conductor. The current through a closed surface bounding the charge is observed to be the instantaneous current given by the equation 0.125 e raised to negative 25 t amperes. Determine the letter A, relaxation time, letter B, the charge transported through the surface in time 5 tau, and letter C, the initial charge within the medium. So to solve for letter A, which is the relaxation time tau, so we can look at the instantaneous current equation given by 0.125 times e raised to negative 25t and comparing it with the general equation for the current or instantaneous current, which is given by the amplitude I times e raised to negative t over tau, where tau is the relaxation time. So by comparing these two expressions for the instantaneous current, we can conclude that the relaxation time or tau is 1 over 25 seconds. So for letter B, the charge transported in 5 tau, so we can solve that by looking at the equation for the current, which is given by the first derivative of the charge with respect to time. So by rearranging this differential equation, we can get an equation for solving the charge. So that is the integral of the instantaneous current with respect to time from 0 to 5 tau. So by substituting the equation for the current and by evaluating the limits from 0 to 5 tau, where 5 tau is equivalent to 0.2 seconds, so we can get the charge transported in time 5 tau, which is 4.97 millicoulombs. And for letter C, the initial charge within the medium can be solved in the same manner when solving for the total charge transported through time 5 tau, which was solved in the previous item. So by using this equation or differential and integral equations, so in order for us to solve for the initial charge within the medium, we can solve for the charge that is transported as the time approaches infinity, because as time approaches infinity, all the charge inside the conductor will be at the surface, and therefore if we solve for that amount of charge at the surface as time goes to infinity, that's equivalent to the initial charge within the medium. So by solving this equation, we can get the initial charge of 5 millicoulombs.